Hello students, welcome once again to Sort of Sir's classes, and we are continuing the real analysis chapter. Okay, we are continuing the topic real analysis, and in the previous video I taught you about convergent functions, convergent sequences, convergent sequences, right? And we had learned about null sequences in the previous video, and for both of them I had given a few points and also examples, right? Today we are going to talk about a very important topic, okay? And that topic you can mark as anything, number 1, number 2, or a star also you can mark. That would be a Cauchy sequence. Cauchy sequence. So what is a Cauchy sequence? First we need to understand with a simple definition, not very difficult, with a simple definition. Now of course we have to take a sequence. Let us take any sequence. Let us take any sequence, say the sequence is xn. Alright, so when I have taken this sequence, let me also do this. Let us take an epsilon greater than 0 and epsilon can be however small, okay? Also n greater than equal to m, okay? Then xn is said to be a Cauchy sequence if mod xn minus xm will be less than the epsilon. Okay, very important to understand this. When this will happen, this mod xn minus xm less than epsilon, when this will happen, then this xn sequence will be called a Cauchy sequence. And of course this n comma m will belong to natural number. Okay, now let's highlight and make you understand in a better way. So what is a Cauchy sequence? This is the heading. What is a Cauchy sequence? Let's understand. Let us take a sequence. Let us take any sequence, say xn, and then we'll take an epsilon value, and epsilon is greater than 0, but epsilon can be however small, doesn't matter. Epsilon also can be small, very small, but it has to be greater than 0, okay? Also there has to be a n value, okay? There has to be a n value greater than an m value, okay, such that mod of xn minus xm is less than epsilon. And of course n and m, they have to belong to natural number. This is a simple definition. N and m has to belong to a natural number. Now what I want to tell you is this: the n that you will take, it will depend on the epsilon, value, okay? The n will depend on the epsilon. Now reading the definition, okay, everybody doesn't understand it, so we will try and understand from a simple example, okay? So this example is going to be a question, and I am going to do this with another color. So let's do an example, and prove this. Okay, so let's take a sequence. I want to take the sequence as 1 by 2 to the power n. Okay, and of course n will belong to natural number. So let's start with this sequence. Okay, let's start proving Cauchy sequence. So in order to prove Cauchy sequence, what must we have? First one, we must have an epsilon greater than 0. Second one, we must have m greater than n, not m greater than n, sorry. We must have an n greater than m. N greater than m. Yeah, that was the definition. N greater than m. Then the third one, what must we have? We must have mod of xn minus xm less than epsilon. So we have to do this as well as this. So the first one, let epsilon greater than 0 and n greater than m, comma n comma m belonging to natural number. Let's start. So the two parts are over. Now let's start with the third part. So xn minus xm less than epsilon. This will be 1 by 2n. This will be 1 by 2m less than epsilon. Mark this as 1 because we are not getting anywhere from here. Now if you notice, this is what is happening. Note 2 to the power n is greater than 2 to the power m. Why? Since n is greater than m. That implies 1 by 2 to the power n is less than 1 by 2 to the power m. That implies 1 by 2 to the power n minus 1 by 2 to the power m is less than 0. But from here, what we are getting, this part will be less than epsilon. So if that happens, from that part on top there, so 1 by 2m is less than epsilon. Implies 1 by epsilon is less than 2 to the power m. Now what must we do? Now you can see there's a power exponent, so we will use log to understand this. So taking log on both sides, what do you get? Log 1 by epsilon is less than log 2 to the power m. Alright. Now from here, log 1 by epsilon is less than m log 2. Okay. So if you notice over there, how did the m log 2 come? How did it come m log 2? Simple. We know the logarithm rule. The power comes in front. This power has to come in front. Okay, you know the rule. Okay. So now what we need to find out from here is log 1 by epsilon divided by log 2 is less than m. So you see, we have got the value for m, or we have got some value that is less than m. So let's scroll down, no place. So for all epsilon greater than 0, or for any epsilon greater than 0, there exists m that is greater than log 1 by epsilon by log 2. Okay, such that mod of xn minus xm is less than epsilon. Hence xn is a Cauchy sequence. Understood. Let's try and understand it once again. Okay, let's go back. So today we are talking about Cauchy sequence, or in this video we are talking about Cauchy sequence. We have split the videos into small parts so that you can understand. Okay, that's why it's very simple to understand in our classes, in our videos. Okay, so that is actually the difference between others videos and our videos. Our videos, we split the topic into different parts so that you can understand better, rather than keeping it all hodgepodge and putting it inside your brain, like cooking a meal with all different types of vegetables. Okay, so that's gonna taste really bad. So what is a Cauchy sequence? I will highlight and I'll show you what is a Cauchy sequence. So you just concentrate on what I am saying once again, because some of you students have a tendency of copying while somebody is explaining. So if you have that tendency, then you will have to understand after copying it. So that's why I am using this rule, to make you understand after I have already read it. Okay, I have read after I have already done everything. So the Cauchy sequence says what? In a Cauchy sequence, we have a sequence xn, then we need to assume an epsilon greater than 0, okay, such that there will be an n greater than equal to m, okay, and this is the Cauchy criteria. If this happens, then the sequence is a Cauchy sequence. If mod of xn minus xm is less than epsilon, then it is a Cauchy sequence. And of course, n and m will both belong to natural numbers. Now what does this mean? Depending on the epsilon value, the n has to depend on the epsilon value, means you have to compare n with epsilon. Okay, so what is the example next is showing you? Look at this, very nice example. Xn is equals to 1 by 2 to the power n. The first part, what I have done already, first part, epsilon greater than 0 here, then n greater than m here, and n and m belongs to natural number, you have to write. So the condition will be then what? The condition will be this. The next one, the third one, less than epsilon. So you have written this less than epsilon. Now you already know that 2 to the power m is greater than 2 to the power n, because n is greater than m. That means if you do the reciprocal of this, then what happens? The sign gets reversed. Okay, is less than 1 by 2 to the power m, which is less than epsilon. Now this part comes later, this comes after this comes. Okay, so of course 1 by 2 to the power n minus 1 by 2 to the power m will be less than 0, and epsilon is greater than 0. Okay, so this part is less than epsilon. Yeah, so this is less than epsilon. The m part, because why you must be saying, you must be thinking, why not 1 by 2 to the power n is less than epsilon? Of course 1 by 2 to the power n is also less than epsilon, but we are interested in the m part. So that's why we are talking about 1 by 2 to the power m. So if 1 by 2 to the power m is less than epsilon, that implies 1 by epsilon is less than 2 to the power m. Now if you put log on both sides, then you get a simple calculation, and then you get a value that is less than m. You can see this value. Your basic work was to get this value that is less than m. So that means if you are getting a value less than m, that means you can get an epsilon that is greater than 0 and an m that is greater than that value, such that this condition will be satisfied. So this condition is already satisfied. That means xn is a Cauchy sequence. So I hope you all have understood what a Cauchy sequence is. We have completed the convergent part from the real analysis. Now we will be going on to the divergent part, but not for this video. For this video, that is enough. So keep taking as much help as possible, because always help is given at sort of such classes. So thank you for watching.